on public blockchains. Currently, we're on this Polyet testnet, but we're going to be going shortly to the Polygon mainnet. So why do we have oracles? Oracles essentially are a way of being able to connect smart contracts to APIs. So you may have heard of a company like Chainlink. They're doing connections using public APIs, so they're normally connected to the pricing. The problem with oracles like this is that essentially the data can be manipulated by the oracle because there's no cryptographic link there between the actual data and the smart contract. The other challenge is, if I want to connect with a private API, I need to give my API keys and my data to this Oracle provider. The way they work is they all call the API and then they return to the blockchain and say, hey, this is what the result is. So it really leaves open to manipulation. Okay, so what we're doing with Silent Data Oracle is, again, we're using Intel SGX, and this enables us to do privacy-focused Oracle interactions. So what it means is we can allow you to build use cases on top of smart contracts where you can call private APIs, do analysis on the response of those APIs without us seeing the data and without us seeing your credentials. Okay, so to ground this, I'd like to give an example. So one of the things that Simon spoke about was about compliance, right? So we think one of the key things with compliance on public chains is AML. Tokens as it stands don't usually do any kind of AML checks before transfer. So what we'd like to go through here is a quick example of how you could perform an AML check on every single transfer. So have a token, say a stable coin, where the only people that can receive it are people that are on a AML whitelist. That AML whitelist is actually connected to Chainalysis and Elliptic. The example I'm going to run through now is a connection with Chainalysis. But essentially making sure that no one who's connected with illicit funds can hold your token. Okay. So in terms of how this is actually configured, so we don't require any modification on the Chainalysis API. So I can say, okay, I'm triggering from my smart contract, and I want to pass an address that I want to check before I send them funds or before they can receive funds from my token. So I configure here multiple steps. So the steps are to call the Chainalysis API. First, I call it to register an address. I check the response, and I check that the address risk score is low. I'm checking a low risk score. I don't want anyone with a high risk score or a medium risk score to hold my token. So then we'll call back the smart contract, and we'll register that result.
So in terms of how this is used within the smart contracts and within our token, we can see that if I go to my token and I try to send some tokens to a client, so say I select the client and I say, okay, I want to send them 10 stablecoin tokens. I confirm this transaction. We'll see the transaction fails, right? So why does the transaction fail from my wallet? The transaction fails because this user is on the whitelist, right? So what I'm going to do is I'm going to request that the receiver is added to the whitelist. If I confirm my transaction, so I paste their address in and I confirm the transaction. We wait for that transaction to go through, and this is going to trigger the silent data job. So the silent data job that I showed configured earlier, you can see that it's been triggered and it's been successful. But success means that it's posted back on chain. So now if I try exactly the same transaction as I tried previously, so if I select again the same client that has now been added to the whitelist, and I hit confirm to send that transaction, and we wait for that transaction to go through. So you can see it's pending, and then when it's confirmed, the transaction's gone through, so they've received the balance.